Assalamu alaikum. Today we are going to start a topic in maths, scale factor. That's the easiest and precise topic and yet interesting one as well. I'm going to start it in storytelling form so that you can understand it well. So before writing the definition, I'm writing it side by side and I'm telling you the story. The magic of scale factor. Once upon a time, in a classroom full of shapes, the teacher introduced a magical tool called the scale factor. It's not a ruler, she said, but it can make things bigger or smaller, just like magic. All the sheep gasped. How does it work? Asked the curious little triangle. Well, the teacher smiled. The scale factor is just a number. It's if it's more than 1, the shape gets bigger. If it's less than 1, the shape gets smaller. But no matter the size, the shape always stays the same. The square raised its hand. Why do we need it? Great question, said the teacher. We use a scale factor to resize objects in maths problems, shrink big places into small maps, create house plans from blueprints, design tiny toy cars from real ones, and even build worlds in video games. The rectangle whispered, so it helps in real life too? Exactly, the teacher nodded. Architects, artists, engineers, and game designers all use scale factor every day. It helps us make models, drawings, and even measure distances easily. And so the class learned the scale factor wasn't just a math idea, it was a super useful tool in the real world. From that day on, they never looked at shapes the same way again. So, I hope that you have liked the story which I've just told you. So, having the simple definition in maths, we are just using this tool to make the things, make the shapes bigger or smaller. They are largely used in daily life. I have just told you the objectives, maps, places. You can resize your objects. You can create house plans like architects do, and design your tiny teeny cars. You can build your houses and roads and worlds in your video games as well. So it is so useful in daily life. So let's get move on with the scale factor thing. Let's find out how interesting it is. Well, when we do things in our daily life, we have certain criteria, we have certain way to solve the things, sort the manners, sort the things around us, and sort our problems, right? So in similar way, maths have a specific formula for everything, each and everything. So scale factor has new area or new size or new shape ratio the older size. That's the scale factor. That's simple, as you can see, and you are going to find it more interesting when we solve some exercises and the examples, inshallah ta'ala, in the coming up lesson. So we do use it with shapes as well as the area. When we talk about shapes, we get areas. When we talk about shapes, we got volume as well in our mind, because two-dimensional spaces, one-dimensional space, and three-dimensional space are the beauty of the geometry, right? So here's this example over here with the lengths given to us. The original one is 5 centimeter, the new one is 15 centimeter. So we have to find out the scale factor. So putting up the specific formula, new upon the older, we will get 5 centimeters upon, sorry, the new one is 15. So 15 centimeter upon 5 centimeters, and it's so simple to simplify here and get the unique answer. So you know that 5 times 3 is 15, centimeter cancelled itself. So it's, your scale factor over here I'm writing clearly 3, right? So this is how you can use scale factor formula and get the answer. Isn't it easy? All right, then now move on to area. Let's talk about area. Since area is a two-dimensional space, what we have a specific formula again, length into breadth or length into width, you can say. That's how we use area. So a scale factor will be squared over here while dealing the area. Since it's a two-dimensional space, we are simply going to square it and times it with the area, that one, that is original or older one given to us, right? So this is the simple way in order to find out the area using scale factor. A scale factor will be squared. Let's suppose we have a rectangle over here. You know that rectangle has a length, opposite sides are equal, so length and the width. So length is given to us 4 and the width is given to us 2. So what we are going to do, find out the new area using the same dimensions. So SF is given to us 3, so we are going to times it in order to get the new one. So new length is from 4 to 12. Why? Because we have times it with the scale factor, that is 3. So 4 times 3 is 12 and 2 times 3 is 6. So new length, new width is given. New area will be find out. It will be 12 times 6. 6 2 times is 12 and 1 carry, 6 1 6 72 centimeter square. That's your new area. This is how you get the answer using area and scale factor. Easy peasy lemon squeezy. So you can see that the older one was the area 8 and that new obtained is 72. So from 8 to 72, the scale factor you can easily find out that it is 9, right? If you squared 3, then you will find, definitely get 9. Here we have another example. Having a square, you know that square has all the sides, all 4 sides equal. So that's so simple to find out the area of a square, that is side by side or length multiplied by length, you can say anything. So side by side, that is s square. So we will square the side. 5 square centimeter square, it will be 25 centimeter square. Don't forget this units, please. I forgot to write. All right. So new area we are going to find out by using the scale factor. We are squaring it and we are going to times it with the area, which is older one. So the older one is given to us. We have determined the older area, that is 25 centimeter square. We are going to put it, and using the scale factor squared, it will be 2 square times 25 centimeter square. So 2 times square means 2 square means 2 times 2, and that is 4. So writing 25 times 4 centimeter square, it will be 100. We are going to write 100 over here. So the new area obtained is 100 centimeter square. You can see that from 25 to 100, it's just got bigger using scale factor 2 or 4, right? So what we have just done, squared the scale factor and times it with the original or the older area. So in order to find out the new area, this is the simplest formula using scale factor. So similar way we are going to apply things on volume. Since volume is a 3-dimensional space, it has its own protocol having 3 components: length, breadth and height, or what you can say width, and the unit will be in cubical unit, right? because 3 dimensions here, so 3 units will be there, so it will be cube. Now the formula will be as same as area we have applied, but slightly difference will be that we squared in the area, the scale factor was squared, and in volume we are going to cube it, right? So scale factor will be cubed and times it with the older volume. So putting the values, we will get the desired answer for each and every question for ours. So let's pick up a example having a cube equals to 2 centimeter, right? And here scale factor is 3, so we are going to cube the scale factor, and since the volume is length, breadth, height, so it's a cube, so all sides will be s cube, right? So s cube will give us 2 cube, and 2 cube is equals to 8 centimeter cube. So 8 centimeter cube is the volume we have obtained. Here we are going to cube the scale factor and times it with the obtained volume. Scale factor is 3. We are going to put it over here. 3 cube, 8 centimeter cube. So you know that very well. 3 cube means 3 times 3 times 3. That is 27. This is how we do it. Just make it precise for you so that you cannot get confused. So 27 times 8 centimeter cube will get the answer as 216 centimeter cube. That's the new volume using the same scale factor, cubing it and times it with the area, original one. Scale factor was 3 and the volume was 8, right? So how we obtained the volume 8? By using the side 2. Putting in the value all the in the formula. So here we are getting 3 times 3 is 27, and then times it with 8, you got the new volume. This is how we done it. I hope that you have understood it completely and found it so interesting as I have enjoyed it teaching you. Let me know if you have any query. Let me know if you are getting stuck in any of the question using solving your scale factor chapter, whether it's a area, it's volume, whatever. Thank you for watching. Keep me in your prayers. Allah Hafiz.